Now, on the next page, we're going to talk about something called quadratic form. And what that means, you can think about like even quadratic functions. Well, that's obviously a quadratic form. So this would be quadratic form. And we had x squared plus 3x minus 4. And we would factor that. We had something squared, x squared, plus 3 of that same something, x, and then minus a constant. But what if this something itself was x squared instead of just being x? What if this middle term said 3x squared? Well, if we had x to the fourth plus 3x squared minus 4, we have something squared plus 3 of that something minus 4. It just happens to be that this something, that thing being right here with the 3, is x squared. And when we square x squared, we get x to the fourth. This means we could do anything. What about x to the 10th plus 3x to the 5th minus 4? We can factor that the same way because our something here is x to the 5th, and we have that something squared in the front. X to the 5th squared, multiply the exponents, you get 10, plus 3 of that something, x to the 5th, minus a constant. So this is in quadratic form, and we can factor those the exact same way we did quadratics back in Unit 1, things that look like this. What that means, though, is that our factors are going to look different. Our factors, instead of being like in this form, x minus 1 times x plus 4, if we're looking at this one, we would say x squared minus 1 times x squared plus 4. Whatever this something is, this middle term, that's going to be the x at the front of your parentheses. So we have that down here. If we're x to the fourth, it's going to be x squared plus an x squared, the thing in front of both parentheses. And then if it was the sixth, well, half of 6 is 3, so x to the third and x to the third. Because when you multiply these together, you would get x to the sixth. So let's look at some examples. We'll do a couple of these together, and then I'll have you try some on your own. So like always, we want to look for a GCF. The GCF of letter A, example A here, is 16. So I'm going to factor out a 16, and then I'm left with x to the fourth minus 16. This is actually a type of difference of squares because the square root of x to the fourth is x squared. So we can write this as x squared plus 4 times x squared minus 4. And if we were to FOIL this out, multiply this out first, outside, inside last, we would get x to the fourth minus 16. Now, this isn't done yet. This is also a difference of squares. So now we write that as x minus 2 times x plus 2. So this would be our factored form. Over here in letter B, we're going to factor out a 3m squared, and that's going to give us m to the 10th plus 18m to the 5th plus 17. Now, again, we're going to factor this, and this is in quadratic form because we have 18m to the 5th. m to the 5th is our something, and our leading term is that something squared. M to the 5th squared is m to the 10th. So let's think about what two numbers multiplied as positive 17 but add to 18. Well, that's going to be 17 and 1. So this is going to be our factored form. M to the 5th plus 17 and m to the 5th plus 1. But of course, don't forget about that 3m squared in the front that we factored out at the beginning. So this would be our final answer. I'm going to do this one down here, and then I'll have you try the rest. So factor out a 10 from both of these, and we're left with x to the fourth minus 1. This, again, is a difference of squares. So, oops, x squared minus 1. Because the square root of x to the fourth, again, is x squared. This is also a difference of squares. So this would be our final answer. So really knowing the difference of squares pattern, that shortcut, makes life a heck of a lot easier here. So I'm going to have you guys try the rest of these. Once you're done, unpause the video and we can compare answers. All right, so check your answers. For that first one, letter C. Once you've found two numbers that multiply to 45 and add to negative 14, negative 5 and negative 9, you then had to do the difference of squares with x squared minus 9 to get this answer. And actually, this should not be squared. So that would be your completely factored expression. And then down here, you can see both of these answers right here. After you factored out the GCF, you actually got the exact same. You actually got the exact same result once you factored out the GCF. And the two numbers that multiply to positive 6 but add up to negative 5 were negative 3 and negative 2. So this is why I stressed in Unit 1 that factoring was going to be super important and coming back to us, because if you were struggling with factoring back then, this may be a struggle now because we really are relying on those skills. So thank you for watching. Make sure to like and subscribe. Today what we're going to be doing is using those factoring techniques that we learned the other day in order to solve polynomial equations. Now remember, back in Unit 1, we first learned how to factor quadratic equations, and then we solved quadratic equations by factoring. We can do the same thing to solve polynomial equations. So in Unit 1, you learned how to use the factoring method, and we had a lot of factoring methods that we learned. To solve factorable quadratic equations. And you can extend this to solve some factorable polynomial equations. Now, when asked to find all real number solutions of a polynomial equation, we got to factor completely, and then, like we did earlier, set each factor equal to 0 and solve and get x by itself. Now, remember, there's a difference between real number solutions and all solutions. If I say real number solutions, then we don't care about I or the imaginary unit. But if I say all solutions, that does include I, that imaginary number, so we have to think about that as well. So let's look at some examples here. First, we got to make sure that the equations equal 0, which this does. All right, equals 0. Now, what I want to do first is I notice I can divide all of these by 4. So divide by 4. And this is going to get me x to the 5th minus 10x to the 3rd plus 9x equals 0. Now they all have an x in common, so I'm going to factor that out. I get x to the 4th minus 10x squared plus 9 equals 0. And I'm going to factor this, and I notice that this is one of those quadratic forms where I have an x to the 4th, an x squared, and no x at all. So I can treat this like factoring a normal quadratic. So what two numbers add up to negative 10 but multiply to positive 9? Well, that's going to be x squared minus 9 and x squared minus 1. And don't forget about that x out in front equals 0. Now we can factor these. These are both difference of squares. So this is going to be x, and then x squared minus 9 is going to factor to x minus 3 times x plus 3. And then x squared minus 1 is going to factor to x plus 1 times x minus 1. And now we're going to set each of these equal to 0. And since all these are 1x's in front, it becomes very easy. We can just say x equals 0, x equals 3, x equals negative 3, x equals negative 1, and x equals positive 1. So we have 5 solutions in this quadratic equation, or this polynomial equation. Now let's look at this one. This one does not equal 0. So we need to subtract 14x to the third from both sides. And that's going to get us 2x to the fifth plus 20, actually, let's write this in standard form, minus 14x to the third plus 24x equals 0. I'm going to divide everything by 2. That's going to get me x to the fifth minus 7x to the third plus 12x equals 0. Now, some people may say, well, why don't we divide by 2x? Divide both sides by x because they all have that in common. If we look back over here, if I would have divided this by 4x up here, then this x out in front that we factored, this x right here wouldn't be there. It wouldn't exist, which means we would get rid of this solution. If we divided both sides by 4x all the way up here, then we would not be able to find or tell that one of our solutions is x equals 0. So you don't ever want to divide by x when we're solving polynomials. We want to factor out an x because that means one of our solutions is x equals 0. So over here, let's factor out an x. X to the fourth minus 7x squared plus 12 equals 0. And then we're going to factor this. Two numbers that multiply to positive 12 but add to negative 7. That's going to be x minus 4, or sorry, x squared minus 4, x squared minus 3 equals 0. And I'm going to start writing over here now because we have x minus 2 times x plus 2 because this is a difference of squares. And then we have x squared minus 3. Well, a lot of people will say, well, x squared minus 3, that's just going to be 3, or is our solution. But no, remember what we set up here. We got to set each factor equal to 0. So yeah, I would agree that one of our solutions is x equals 0. One is going to be x equals 2. Another is going to be x equals negative 2. But for this one right here, we have to write x squared minus 3 equals 0. When we add 3 to both sides, x squared equals 3. And then when we square root both sides, we get x equals plus or minus the square root of 3. So that means we also have x equals negative square root of 3 as a solution, and x equals positive square root of 3 as a solution. So again, like you got to be, this lesson is difficult because we are recalling all of this information from Unit 1 and applying it to polynomials. And like this was a long problem, a long process. We factored out a GCF. We divided both sides by 2. We factored, and then we factored again, and then we then also had to set each factor equal to 0. And this one, and this one made it a little bit more time consuming. Let's look at this one down here. We want all of our, we want this equation to equal to 0, and we have a negative 6x to the fourth here, so I'm actually going to add 6x to the fourth to both sides. And this is going to get me 6x to the fourth minus 27x to the third plus 15x squared equals 0. Now I'm going to divide everything by 3. When I divide everything by 3, I get 2x to the fourth minus 9x to the third plus 5x squared equals 0. Now I'm going to factor out an x squared because all of these have an x squared in common. So x squared, and then I'm left with 2x squared minus 9x plus 5 equals 0. And then we got to look, what can we do with this? Can we factor that? Well, two numbers that multiply to 10, because we got to multiply a times c, but add up to negative 9, well, there are no two numbers. And we learned that when we can't factor something, we have to use a quadratic formula. So that quadratic formula we're going to use, and x equals negative b, so negative 9, so 9 plus or minus the square root of negative 9 squared minus 4 times a, which is 2, times c, which is 5, all over 2 times 2. So we're going to type this into our calculator. And I'm going to do negative 9. I'm going to type in the discriminant first. Minus 4 times 2 times 5. I get 41. So this is going to be x equals plus or minus, 9 plus or minus the square root of 41 over 2. Now, can we simplify that in any way? Well, the square root of 41 can't be broken down, so we're done there. And we can't divide anything out, so those are my two solutions. We also have to worry about this x squared, so my solutions are going to be x equals 0, x equals 9 minus the square root of 41 over 2, and x equals 9 plus the square root of 41 over 2. So we have three solutions in this instead of 4. So this is a fourth degree function. You can see that up here we had 6x to the fourth. So we would expect maybe 4 solutions, but we don't have to have 4 solutions. This one had 3. So now this one, I want to make sure that my leading coefficient stays positive. So I'm actually going to move these things to the other side. So it's going to be 2x to the 5th minus 12x to the 3rd plus 16x equals 0. We're going to divide everything by 2. So we have x to the 5th minus 6x squared plus 8x equals 0. GCF is an x, so let's factor that out. Whoops, this should be to the 3rd. There's no x here. Now we can see if we can factor this. Are there two numbers that can multiply to positive 8 but add to negative 6? There are. We have negative 4 and negative 2. This is a difference of squares. Now for these are going to be simple. So x equals 0, x equals 2, x equals negative 2. But for this, we have to do some work. So x squared minus 2 equals 0. Add 2 to both sides. So x squared equals 2. And then when we square root, we get x equals plus or minus the square root of 2. So we have x equals negative square root of 2 and x equals positive square root of 2. Now, the last ones down here, I know that they say solo and pair, but I'm going to walk you through these as well. So we're going to subtract 10x from both sides. So we have x to the 4th minus 10x squared plus 9 equals 0. Then we want to ask ourselves, what two numbers multiply to 9 but add to negative 10? That's going to be negative 9 and negative 1. And we have the same part up here. So we know now that we could do x minus 3 times x plus 3, then x minus 1 times x plus 1 equals 0. And then our solutions will be x equals 3, x equals negative 3, x equals 1, and x equals negative 1. Now with this one over here, I notice I have x to the third minus 2x squared minus 5x plus 10. This is not in quadratic form. So I'm going to look and see, can I do factor by grouping? Well, I can factor out an x squared from those, so x squared, and I'm left with x minus 2. And then from the next group, I can factor out a negative 5, and I'm left with x minus 2. These match, so I'm in good shape to do factoring by grouping in my leftovers. So x equals 2, but for this, we got to do some work. And then when we square root both sides, we get x equals plus or minus the square root of 5. So we get x equals negative square root of 5, and x equals positive square root of 5. And those would be my 3 answers here. Now, the last one over here, you may be tempted to do the 4th root of both sides, but we want to, again, factor this. So I'm going to subtract 25 from both sides, so x to the 4th minus 25 equals 0. And now this becomes a difference of squares, because x to the 4th is x squared squared. So we can write this as x squared minus 5 and x squared plus 5. Now we got to set each of these equal to 0. So x squared minus 5 equals 0. Well, that's not too bad. We just did that. We square root both sides. X equals plus or minus the square root of 5. But for this one, x squared plus 5 equals 0. Okay, we subtract 5 from both sides. Oh, x squared equals negative 5. And when we square root that, we're going to have the imaginary solution. So x equals plus or minus the square root of 5i, because that negative inside the square root means we have the imaginary solution. So we have x equals x equals the square root of 5, x equals negative square root of 5, x equals square root of 5i, x equals negative square root of 5i. You could leave it as plus or minus form, but I like to write them out so that I, in my own mind, can see, all right, I have all my solutions written out. So I know that this was a complicated lesson because it's combining a bunch of stuff all together. So again, the only way you're going to get better at this is to practice this, and practice it, a lot. And ask questions when you are confused. So if you need to rewatch the video and redo the notes in order to learn it, then that would be a good idea. So thank you for watching. Make sure to like the video and subscribe.